Hello and welcome to a special deep dive report. The date is January 2nd, 2026, and if you look up at the night sky, you are looking at a crime scene, a laboratory, and a mystery all rolled into one. We are tracking an event that is currently rewriting the textbooks on interstellar dynamics. As Earth races along its orbit at nearly 30 kilometers per second, we are currently involved in a high-speed chase with a visitor from the deep cosmos. I'm talking, of course, about the interstellar object 3I Atlas. This isn't just another rock tumbling through the dark. This is a hyperbolic anomaly that has astronomers from the European Space Agency to NASA's Jet Propulsion Laboratory working double shifts. We are now in the final phase of its visit. The object is approaching its point of closest approach to Earth, which will occur on December 19th, just days away in the timeline of this mission's tracking. But before we get into the physics of this encounter, if you want to stay ahead of these breaking cosmic updates, make sure you hit that subscribe button and turn on notifications. We are covering this situation hour by hour as the data comes in. Let's look closer at the data regarding where this object is right now. 3I Atlas is currently positioned in the constellation Leo, shining with an apparent magnitude of 11. To the naked eye, it is invisible, lost in the black canvas of space, but to a telescope of even moderate power, it is a distinct fuzzy point of light that refuses to behave like a standard comet. It is currently located about 270 million kilometers from us. To put that in perspective, that is nearly twice the distance between Earth and the Sun. It sounds far, and in terms of collision risk, it is perfectly safe. There is zero chance of impact. However, in astronomical terms, it is close enough to be scrutinized, and what we are seeing is baffling. The geometry of this encounter is creating a fascinating illusion. 3I Atlas actually passed its perihelion, its closest point to the Sun, back on October 29, 2025. At that time, it dipped to within 1.36 astronomical units of our star, enduring intense solar heat before slinging back out toward the void. Usually, this is when a comet fades. It moves away, cools down, and goes quiet. But 3I Atlas is different. Because of Earth's own orbital motion, we are currently catching up to the comet from behind. We are effectively racing it. This orbital geometry creates the illusion that the comet is approaching us for an imminent encounter, even though it is technically receding from the Sun. This unique perspective is giving us a front-row seat to the comet's outbound leg, a phase where comets often reveal their internal structure as the heat soaks deep into their core. So, what does this actually mean for the observer? It means that for the next week, the viewing conditions are optimal, but the object itself is behaving erratically. We are tracking a velocity of roughly 210,000 km per hour. That is a hyperbolic excess velocity that screams interstellar. This object did not originate in our Oort cloud. It didn't form from the same protoplanetary disk that built Earth, Mars, or Jupiter. It is a wanderer ejected from a distant star system, perhaps billions of years ago, drifting through the interstellar medium until gravity snagged it into our neighborhood. And now it is leaving. But here is the crucial detail that has the scientific community on edge. The trajectory is too perfect. When we model the path of a standard comet, we account for the gravitational pull of the Sun and the planets. It's a complex but solvable equation. 3I Atlas, however, is exhibiting what we call non-gravitational accelerations. In plain English, something other than gravity is pushing it. Now, usually this is caused by outgassing, jets of gas erupting from the surface acting like thrusters. We see this with comets all the time, but the acceleration we are measuring for 3I Atlas is smooth, consistent, and seemingly adjusted. It's almost as if the object is correcting its course. This contradicts what we previously thought about the behavior of interstellar objects. When Oumuamua passed through in 2017, we saw similar non-gravitational acceleration, but 3I Atlas is displaying it with a magnitude and precision that is harder to explain away with simple thermal outgassing models. The gas jets we do see are episodic and chaotic, yet the acceleration remains strangely uniform. This has led to some bold hypotheses. Astrophysicist Avi Loeb has gone on record noting that the probability of this being a purely natural object, given the specific combination of its orbit and its acceleration, is less than 0.005%. He calls it a messenger from the abyss. I want to pause here and ask you, do you think we are too quick to look for artificial explanations, or are we too afraid to admit when nature looks engineered? Let me know your thoughts in the comments below. Now, let's talk about the visual data coming in from the observatories. In the last 24 hours, telescopes from Gemini North in Hawaii to the Hubble Space Telescope have captured stunning new images. The comet has brightened significantly. We are seeing a coma, that's the fuzzy atmosphere around the nucleus, that has expanded to nearly 100,000 kilometers in diameter. That is roughly 8 times the diameter of Earth. The structure of this coma is also peculiar. It is highly symmetric. Usually, the solar wind pushes the coma back, creating a distinct bow shock and a tail. But 3I Atlas currently shows a symmetric coma with almost no visible tail in the optical spectrum. It looks like a glowing green orb floating in the darkness. This symmetry suggests that the outgassing is happening uniformly from the entire surface, or that the dust particles are incredibly fine. However, the European Space Agency's JUICE probe, currently en route to Jupiter, has managed to record interactions between the comet and the solar wind. Its sensors picked up magnetic disturbances, ripples in the plasma environment. The X-ray data from ESA's XMM Newton Observatory adds another layer to the puzzle. They detected a spherical X-ray glow around the comet. Comets do emit X-rays when solar wind ions slam into their atmosphere, but usually we see jets or distinct hotspots. 3I Atlas is glowing uniformly in the X-ray spectrum. It's a cold object wrapped in a hot blanket of high-energy interaction. As we close the gap to that 1.8 AU distance, we are effectively peeling back the layers of this object. The fact that it fragmented after perihelion yet retained its integrity is another massive red flag. Typically, when a comet fragments, it disintegrates. 3I Atlas appeared to fracture, yet the main body remained solid and the fragments seem to be moving in formation. Is it made of metal? Is it a rock with a unique crystalline structure? The greenish glow we mentioned is standard for comets with diatomic carbon, but the intensity of it combined with the lack of a dust tail creates a spectral signature that is incredibly pure. As we move into the next chapter, we need to prepare ourselves for the chemical reality of this object. What the spectrometers are picking up isn't just water and dust. It's a cocktail of organic chemistry that is so volatile and abundant that it challenges our understanding of how life's building blocks are distributed. We are seeing methanol, alcohol, on a scale that is hard to fathom. The headline finding is methanol rampaging far beyond the nucleus. The methanol signal is incredibly strong, and crucially, it is persisting at distances where it should have dissociated. Typically, complex molecules like methanol break down quickly when exposed to harsh ultraviolet light, but around 3I Atlas, the methanol seems to be surviving. Some models suggest that icy grains are being lifted off the surface and are sublimating thousands of kilometers out, releasing fresh methanol as they travel. This implies the comet is shedding its skin in a way that creates a massive alcohol-rich halo. Beyond methanol, that eerie electric green color comes from diatomic carbon, C2. The intensity of the C2 emission is off the charts relative to its dust production. Usually, a comet outgassing this much is also throwing out a lot of dust, silicate particles, and grit. 3I Atlas, however, is remarkably gas-rich and dust-poor. It is a ghost. This suggests a composition that is almost entirely icy or volatile, lacking the rocky matrix that holds most comets together. It's like a block of frozen atmosphere. This unique chemistry points to a unique origin, perhaps a star system with a completely different chemical abundance ratio. Mystery deepens when we look at the physical structure of the outgassing. High-resolution imaging has revealed episodic gas jets that create spider legs, dynamic, filament-like structures extending from the nucleus. These legs suggest that the jets are interacting with the magnetic field of the solar wind, getting twisted into spirals. This indicates a complex surface topography, perhaps with chimneys that channel the gas into distinct streams. And then there is the resilience. If it were a loose pile of rubble, thermal stress should have torn it apart by now. The fact that it survived suggests the core is monolithic, a solid, coherent body. Just as we were analyzing the main body, NASA dropped a bombshell. 3I Atlas might not be traveling alone. Deep field surveys detected a second, fainter object moving on a parallel track. This sister comet is racing alongside 3I Atlas, matching its hyperbolic velocity and vector. This is not a recent fragment. The distance between them suggests they have been a binary pair for a long time. The existence of a sister object forces us to reconsider the fragmentation event. Was it a breakup or the separation of a long-term binary system? If both objects exhibit synchronized non-gravitational shifts, it implies a shared mechanism. The synchrony with a recent gamma-ray burst has fueled even more speculation. Could the anomaly be related to a high-energy event that activated these objects? Avi Loeb's hypothesis of artificial origin gains a new dimension here. If you were sending a probe to another star system, you might send a backup. The sister discovery also explains the spider legs. The gravitational interaction between the two bodies could be pulling tidal streams of gas between them. It's a dance of ghosts in the dark. This means the mass estimates for 3I Atlas might be wrong, as we were modeling it as a single body. But while we look up at these travelers, a disturbing silence has fallen closer to home. The NASA MAVEN orbiter at Mars has gone dark. MAVEN was tasked with a special observation run of 3I Atlas from a unique vantage point. It took the pictures, then passed behind the red planet for a routine occultation. But it never reappeared. Mission Control calls this the gray zone. When MAVEN was expected to emerge, the Deep Space Network remained static. No heartbeat, no telemetry. Telemetry received just minutes before showed all systems were normal. The spacecraft didn't degrade, it vanished. Was MAVEN silenced because of what it saw? Or did the comet's magnetic signature create a localized jamming effect? The loss of MAVEN blinds us on the far side of the system. We have lost our eyes. As we move toward the final chapter, we must synthesize these events: a visitor breaking the laws of cometary physics, a coordinated binary arrival, and the blackout of a major scientific asset. The panspermia engine hypothesis suggests 3I Atlas is a seed pod, the starter kit for life, mixing the gene pool of the galaxy with our own. The closest approach on December 19th will allow our radio telescopes to blast it with radar and the James Webb Space Telescope to analyze its spectrum in unprecedented detail. The unmasking of 3I Atlas is imminent. Whether natural or artificial, the answer will rewrite history. The countdown to January 2nd is not a countdown to disaster, but to a revelation. 3I Atlas is leaving, but it has woken us up. It has reminded us that the sky is not a wallpaper. It is a frontier. And this visitor may not be the last.